Hello everyone. The title of our project is Equation Solver based on pattern recognition. This project was done under the guidance of Dr. B. Shankarababu sir, Professor and HOD of the Department of CSE. The team includes Arnav Nadimanti, Bhima Ranath, Kesari Mithilesh Reddy and Pallerla Suman. The basic idea of our project is to bridge the gap between handwritten equations and digitally solving these equations. And this is done by feeding the system an input, and this input includes the equation and how the system solves it. So, coming to the proposed architecture of the system, it starts off by giving the system an input. This input can be given either by writing an equation through the system sketchpad, or we can choose to upload an image. And once the image has been uploaded or written, we can save the image. The process of solving the equation begins by saving the image, and after that, the evaluation takes place. And in the backend, once we have saved and started the evaluation process, the first thing that takes place is binarization. So in most uh, equation solvers, CNN is used, but an issue with directly using CNN is that it cannot accurately determine or generate the equation. This is because everybody has a different style of writing an equation. So for this reason, what we choose to do is first implement OCR. We first implement OCR, and then we're going to give that blueprint to CNN so that it is much easier for CNN to determine the equation. So the very first thing that takes place is binarization. And binarization is a process in image processing that converts a grayscale or color image into binary image, where each pixel is represented as either black or white. And this technique simplifies image data, making it easier to analyze. So this is a little about binarization, and this comes under OCR. So once we have the option to set a threshold value, and when we set this threshold value, it is very easy to determine whether an object comes into the foreground or the background. And once binarization takes place, we move on to line segmentation. Line segmentation is a crucial step in document analysis and optical character recognition. It basically involves identifying and isolating individual line of our text from within the equation. And this process really simplifies the task of recognizing that equation by first breaking it down line by line. And once line segmentation takes place, we get character segmentation. And character segmentation, it is the process of isolating the individual characters of each line. And it typically involves using OCR, and once each individual character has been segmented, it becomes very easy to identify which character it is. And then we move on to the CNN model, where the CNN model detects patterns and structures within the equation, and it captures the spatial relation between symbols and characters. So here, once the equation has been generated, which takes place in the next step, we can identify the equation, what each symbol means, and then we can solve the equation. And once the equation has been solved, the system displays the solution. And the solution is displayed in two parts. It is either displayed in the terminal or it is displayed in the UI. So moving on to the different modules that we have, first comes the interface. So implementing a section or button allowing users to upload images of handwritten equations or capture them using the device's camera, and also including clear instructions and visual cues to guide users through the process. We will display a preview of the uploaded captured image to confirm correctness. And this allows users to review it, and if needed, they can re-upload the or recapture the image. And image recognition and character segmentation. This module will typically involve using image processing techniques to enhance the input image and then applying OCR to recognize the text. OCR libraries such as Tesseract can be used for this purpose. We may use mathematical libraries like SymPy for symbolic mathematics or evaluate the expression using an interpreter if you're working with a simpler expression. And the parsed equation should be returned as a string. And evaluation and equation reconstruction. The evaluation process in a handwritten equation solver involves assessing the quality and correctness of the parsed equation and the accuracy of the solution generated. This evaluation is necessary to ensure that the solver produces reliable and meaningful results. Coming to our main method, we have a directory called segmented, and this contains each mathematical symbol in the image. So we first start off by installing all the dependencies. We have segmented directory which contains each mathematical symbol in the image, and the path and models are trained so that it is capable of recognizing the unique handwriting of each individual, and a CSV file that maps the numerical code to the character is also provided. And once the image has been given as the input, segmenting of each character takes place, and then the segmented character is written to the segmented directory. And this is where the recognition takes place. So before we start solving the equation, right after we have recognized it, the image is compressed so that it becomes easier for analysis. Each individual segmented character is predicted and identified, and then this process takes place. So resizing also takes place. This is so that the compressed image is a lot easier to handle for the system and analysis becomes much more easier. The calculation part also involves recognizing each and individual command. For example, if it's an operand, it recognizes it as an operand. If it's an operation, it recognizes the symbol as an operation. And then once it finds the equal to symbol, it realizes that I have the left hand side of the equation, I have the right hand side of the equation, and then proceeds with the solution. So this is what the UI looks like, where you can draw the equation or choose to upload the file. And once you have uploaded the file, you can hit evaluate. The first thing that takes place is resizing the image. The image is resized and then it is solved. So in conclusion, handwritten equation solvers are designed to convert our written math problems into digital format and enabling computers to effortlessly understand and solve them. With the help of advanced tools like CNN and OCR, these systems can adeptly read a variety of handwriting styles, transforming scribbles into structured equations. These solvers are becoming invaluable assets for students, teachers, and researchers, offering a quick and efficient way to verify and solve mathematical problems. As we continue to refine this technology, its accuracy and capability to interpret complex writings will only expand, showcasing the growing synergy between human tasks and computer assistance. These kind of equation solvers can prove to be a blessing, and with advancement in technology and algorithms, we can make it so that we are able to include the steps to solve these equations, thus providing more than one way to solve the equation, making it a useful tool. So I'll show the execution part now. The process starts off by entering the command npm start. This works with the React script and gives us the development server, the localhost 3000. This is where we can see our UI. This is the place where we can draw the equation. We have options like save, clear, you know, uploading the image, etc. And the next step involves opening a new terminal and moving on to equation solver main directory. And here we enter the command python m flask run. This is to run the Flask application, and this is the development server. So now that we have everything we need, we can directly enter the input. So let's say I take the equation 2x square plus 3 equals to 5. I first save the image and then I choose to evaluate it. And if you can see here, the very first thing that takes place is the resizing of the image, and once that takes place, noise removal and character segmentation takes place. The equation and operation are recognized and the solution is generated over here in this step. And this is also reflected in our UI, where the entered equation is then formatted into the equation that is written here, 2x squared plus 3 is equal to 5, and then the result is generated, which can also be seen here, minus 1 comma 1. So that's it from my side. This is the equation solver based on pattern recognition. Thank you.